In previous videos covering bond types, we talked about how a bond between a metal and a nonmetal is called an ionic bond, and a bond between a metal and another metal is a metallic bond. So today we're going to address the elephant in the room and figure out what a bond between a nonmetal and a nonmetal is. And we call those covalent bonds. So again, a covalent bond is a bond between a nonmetal and a nonmetal. Sometimes it might be a bond between a metalloid and a nonmetal, because as I've said before, metalloids tends to act like nonmetals in bonds. So sometimes there's some exceptions where we have metalloids with a nonmetal, but typically it's a bond between a nonmetal and a nonmetal. Another important characteristic of covalent bonds is that there's a difference in electronegativity of less than 1.8. So if you take, so here we have an electronegativity chart or a periodic table with electronegativity values. And if we have a bond between, let's say, oxygen and carbon, well, let's take those values. The higher number minus the lower number, we get 3.5 minus 2.5. That's 1.0. So for a bond between carbon and oxygen, we're going to say that that is a covalent bond because we've got a nonmetal bonded to a nonmetal, and then the difference in electronegativity is less than 1.8. There are different types of covalent bonds. If there is a, and we categorize those based on the level of difference in the electronegativity. So if we have some difference in electronegativity, so it's less than 1.8, but it's greater than 0, we're going to call that a polar covalent bond. And then on the other hand, if we have a difference in electronegativity of 0 or very close to 0, for the purpose of this class, we're just going to go with the value 0. But if we have a difference in electronegativity of 0, we're going to call that a nonpolar covalent bond. So nonpolar covalent. And you might ask, what does polar mean? We have the terms polar and nonpolar, so obviously it means something. And polar is just whether there's an even distribution of things. So if something is polar, that means there's an unequal distribution of things. And it can be anything. In the context of this, we're talking about electrons. In the context of other science, it might be magnetic field. That's how you have the north and south pole of Earth. But polar just means an unequal distribution of things, or maybe you have something at a pole versus something not at a pole. So an unequal distribution of something. And then nonpolar, it just means not polar, so there is an equal distribution of things. So those what the two terms mean. Let's go through a couple of examples of a polar covalent bond and a nonpolar covalent bond. So again, it's defined as the difference in electronegativity. If we have a difference of more than 0 but less than 1.8, we're going to call that a polar covalent bond. If we have a difference of 0, that would be a nonpolar covalent bond. So we got two examples here. We've got HF, so a bond between hydrogen and fluorine. And in one of the next videos, I'll show you how to form the bonds. But we have hydrogen's Lewis dot structure, and then fluorines. And what you do is You just connect the dots, and it looks like that. All right. So we have this bond here, and it's going to be important to refresh on your understanding of what electronegativity is. So recall that's the definition of electronegativity is the electronegativity is like the distribution of electrons or like the tendency to attract electrons. That's the definition of electronegativity. The tendency to attract electrons in a chemical bond. So we have a chemical bond right here, and fluorine has an electronegativity value of 4.0, whereas hydrogen has an electronegativity value of 2.1. And this one's a little bit weird. It's got a value of 1.9. We're going to call this an exception and say that it's a polar covalent bond still, if you want to be technical. But regardless, we know that there's an unequal distribution of electrons because within this bond here, because because fluorine's electronegativity value is different from hydrogen's electronegativity value. Okay, and so even though we're sharing electrons here, covalent bonds share electrons. That's going to be another important thing to write down. So actually, let me do that right now. That's a very important thing to write down. We said that ionic bonds are the giving and taking of electrons. Well, covalent bonds are the sharing of electrons. All right, so let's get that written down. That's a super important thing to know. So a covalent bond is where electrons are shared. And I'm sure I will talk more about that later. So they are shared. They're not giving and taking. They're shared. Okay. Anyway, so these electrons right here, they are shared between the bond between hydrogen and fluorine, but they are not shared equally. Fluorine has a high electronegativity value. That means it has a higher tendency to attract electrons in a chemical bond. Specifically, since this is the only chemical bond that exists for this compound, it's talking about this specific chemical bond. So this chemical bond is made up of electrons. If you go back through the video, you see that I originally had a dot here and a dot here, and I connected them. We'll talk more about it later, but this line represents those two electrons being shared now. And but again, it's not shared equally. If we were to kind of draw it to represent that, there's a lot more electrons here on this side of the chemical bond than there are on the hydrogen side. So we have this chemical bond, and the electrons are not being shared equally. And since they're not shared equally, we call that a polar covalent bond. And so what ends up happening is, since we have more electrons here on this fluorine side than on the hydrogen side, we're going to say that there is a partial negative charge on the fluorine side. So I'm really bad at drawing the symbol, but there's a symbol that looks somewhat like that. And then you're going to say negative. So there's like a partial negative charge and a partial positive charge over here. We don't say that there's a full-on negative charge here and a full positive charge over here, because they're still sharing electrons. It's not a full charge on either side, but since more electrons reside on the fluorine side, we're going to say that there's a partial negative over here, and I'll try my best drawing that symbol. It looks somewhat like that. And then the partial positive over here. So again, there are more electrons over in this region. So we're going to say, since there are more electrons over here, or like within this bond even, more of the electrons go on the fluorine side. That means that there's a partial negative charge. There's more of a negative charge on this side than there is on the other side. So a partial negative charge on the fluorine side, partial positive charge on the hydrogen side, just because it doesn't have as many electrons. This is also represented in one of these models. I forget what it's called, but the red represents where there's more electrons. So as you can see, we have fluorine and we have hydrogen. Can't see that. And we have hydrogen. And the red represents where the electrons are. So there's a lot more electrons over here on this side than there are on the other side. Blue represents lack of electrons. So if you notice, yes, fluorine has more electrons to begin with over here on this side. It has those 6 electrons around it. But it also, within this chemical bond between the two, more of the electrons are on the fluorine side because it has a higher electronegativity value, and so the electrons are being pulled that way more. All right, let's go over to this nonpolar example that we have. And here, nonpolar examples, the most common examples are really just going to be when something is bonded to itself. So in this example, we have H2. It could also be O2 or N2 or F2. Anything bonded to itself is going to be a nonpolar covalent bond. Or any nonmetal bonded to itself is going to be a nonpolar covalent bond. Let me specify. So here we have H2. So we're going to have hydrogen, has 1 electron. There's another hydrogen with 1 electron. We'll talk about in next videos that you just connect the dots. And we've got H2, so hydrogen bonded to hydrogen. And we want to see how the electrons inside of this bond are divided up. Well, the way that we see that is we see, okay, this hydrogen is pulling with a certain amount of force, and that amount of force is determined by its electronegativity value. Then this hydrogen is also pulling with a particular amount of force, and that particular amount of force is determined by its electronegativity value. But since these both are the same element, they are going to have the same electronegativity values and therefore pull with the same amount of force. So whatever this hydrogen is pulling with, this hydrogen is pulling with equal and opposite force. So the electrons, so we can say that the electrons in this bond here between the two, the electrons are even, actually they're completely evenly spread out, because the way that we determine how they're going to be divided up and how they're going to be spread out, whether we get more on one side or the other side, is determined by the difference in electronegativity. But since there is no difference, hydrogen's electronegativity is 2.1, and 2.1 minus 2.1 is 0. So if we have no difference, then there's going to be an equal spread of electrons. And we can also see that in that same model, except now drawn for H2. So green represents that there's like an equal amount of electrons. So we notice that the entire thing's green because there's a completely equal amount of electrons in all parts of this. So again, we've got 2 of the same elements, so they're pulling the electrons with an equal amount of force, so that causes there to be an equal spread of electrons. So again, polar means that there's an unequal distribution of something. In the context of chemistry, it's going to be talking about electrons. And so an unequal distribution of electrons. And so that means that within this chemical bonds, these electrons are not spread out evenly. In this case, fluorine has a higher electronegativity value. So whatever element has the higher electronegativity value, the electrons are going to exist more on that side of the chemical bond. and that creates a partial negative charge on that side and a partial positive charge on the other side. And we call that a polar covalent bond. A nonpolar covalent bond is when there is no partial positive or partial negative, because there's a completely equal distribution of electrons, or very close. Some textbooks, when I was in college, I learned it as a difference in electronegativity of less than 0.5. That might be true, but for the purpose of this class, we're just going to go with the value of 0. And typically that's going to mean that you have the same one element bonded to the exact same element. Hopefully that was helpful. We'll go in more detail about covalent bonds here shortly in the next few videos.